Okay. So we already covered some of the basic stuff in Linux. So now we're going to talk a little about administration and security. So real quick, this is what we're going to be talking about as far as administration is user management, application management, process management, and daemons. And I split those two, even though a daemon is a process, it's just the way you control it. It's a little bit different. That's why I split those two. If you can see on the top left corner, there's a little red, orange square. You can mouse over that, and some of the slides have notes. It'll go ahead and pop in on the screen. Okay, as far as security, we're going to talk about users and groups, file permissions, and ownership. That's very important when it comes down to security. Who can do what on the system? It's very important. Processes and daemons, networking, some local policies, and what I call the paranoid mode. And I have a little new security checklist, which is very basic, nothing too crazy on that list. Okay, so administration. Once we install the system, obviously we only have one account created on the system. It was Joe on the demo that I did earlier. But what if we want to have more users on the system? Obviously, it wouldn't be too helpful for everybody else if only one person can log in. So here's some of the tools that you could use to add users into the system. Now, excuse me. So there's the add user command. There's also a user add. There's a difference between the two. One of them is a wrapper for the other one, and it's just a script that prompts you for the user password. It prompts you for other information like the name of the individual, phone number, things like that. Those are just comments that go into the one file, which other applications that access the password file, it'll read it and it'll populate it. It'll look all nice and pretty on the GUI. Same thing with the add group. So you have different groups. You have the administrator group. You have the wheel group, which is the original administrators group for root. You also have a personal group. You can create your own group. That way you can share things with coworkers and still be safe. That affects who can do what on the system. So if you are part of a group and you grant rights to other individuals in the group, you can have access to the files and still deny access to other people that are not part of the group. Obviously, if you add users, you want to delete them too. So you have that command there. The command groups, not to be confused with the file group. The command groups actually list what groups an individual is part of. It could be yourself. If you're on the terminal and you type groups, it'll list the groups that you're a part of. Or if you type groups space a user ID, it'll display the user ID's groups. The file group is actually a text file that contains a breakdown of every single group on the system and every user that's associated with that group. So the command groups actually reads that file. Now, sudoers, it's a file that has the permissions for who can do things as root, what users can actually elevate their privileges while they're doing some type of system administration or trying to run a command. And I mentioned earlier that wheel used to be the original administrators group for root. Now they have an admin group, which the first user that you create on the account, on the system, when you installed it, it's by default part of that group. So that's why you can, only with one person, you can still do things as root and be able to administer the system. So application management. It's a lot of things here, right? So Applications. The way you install applications, basically they come in a package. Think of a package of like a zip file in Windows. You can actually install applications, from zip files in Linux also. They're not necessarily compressed. It's just a container. It's just one place that you can have all the files that you need for that particular application. So a container, usually it has a manifest, which is a list of all the files that are included on that container. A list of dependencies, that way when you try to install it, if it requires some of the libraries, it'll go and look for them also and install them. And obviously it has the application. So containers are .dev. The extension of the containers usually end with .deb, DEB, which is a Debian package. So anything that's Debian based, so Ubuntu, Knoppix, and many others, they use those. The ones that are Red Hat based, they use something called RPM. So it's Red Hat Package Manager. Pretty much they do the same thing, they just have differences on how they handle the dependencies. So those are not the only two, there's plenty others. There's other ones that, that use a tarball, which is like a compressed zip file. Slackware, they do that. Gentoo, they use ebuilds, which is just a script that says, I want this file and these are all the dependencies. I have to install the dependencies first. It'll sort that out for you. The applications can be precompiled binaries, so just an executable, or it could be just a source code that you have to compile once you get it into your system. You can install and remove applications using dpackage on Debian base, or in this case Ubuntu, or RPM command. So I downloaded the Chrome browser. It's on the it's also on the CD, so you can go ahead and practice how to do it. There's many ways of doing it. You can use the GUI. There's, like I said, there are menu-based and GUI-based package managers. Basically, if you're using the GUI, you can double-click on a package, and the associated package manager is going to open up, and it's going to say, okay, I recognize this package. Do you want to install it? You click yes, and it'll go ahead and handle the dependencies for you and install it. If you're doing it from the command line, you would type, in Ubuntu, you would type dpackage space tag I for install, and then the package name, and it'll go ahead and basically run through the same thing. It'll say, okay, I know you got these other dependencies. I'm going to go download them and install them for you. So apt-get and synaptic, those are, one is a command line, and the other one's a GUI-based package manager for Debian-based distros. Yum and PackageKit are for Red Hat-based distros. So I mentioned this before, once you install it, you can run the application from its local directory. Either you cd into the directory where it's at, and then just type / and then the name of the app, the file you want to run, or you can just put the full path of the application. Something else is that sometimes you can type the name of the application. It doesn't matter where you're at in the file system, and it'll run. That's because the path or the location of that file, it's already in an environment variable called path, $path. So I'm going to show this here in a second. And I already mentioned this. You usually run by putting / if you're on the local directory where the application is, or just the full path of the application to run it. So on the example that I did earlier, I was running Firefox. I'm going to show you where I'm at. So pwd, present working directory, that shows you the directory that you're currently in. Which tells you the path of the application that you're looking for. So I'm currently in my home directory, /home or /Joe. Firefox is in user bin Firefox. I can run Firefox from here without having to type user bin Firefox. If I do this, it'll run fine, no problem, because I'm giving it the full path. But if I just type Firefox, see, I can tab complete it if it'll finish the name there for me. If I run it, it just works without me having to specify the path. And I didn't background it, so the reason that is I have this variable. Every time I log in, it gets loaded into memory, and it says every time I run an application, I want to look in these directories first. So I just echo basically repeats what's inside of whatever you pass it. In this case, it's my path, the variable. So it's saying that as soon as I run an application, if I don't put the full path of it, it's going to look in user local sbin first. If it doesn't find it there, it'll look under user local bin. If not, user sbin, and it'll continue going down the list until it finds the application you're trying to run. If it doesn't find it, it'll say, sorry, I can't find it. Then you're going to have to look for it. So if you see here, Firefox is under user bin. When I ran it, the shell immediately looked under, oops, that's too much. Immediately looked under user local sbin, wasn't there. User local bin, wasn't there. User local sbin, wasn't there. Finally found it here, and it ran it. So these are the things that I was talking about earlier, that the shell takes care for you without you even knowing it. Okay. Right. Process management. So every time you run an application from the command line, or even if you just run it from the GUI, you see sometimes what happens if it's a GUI-based application. Like in this case, I ran Firefox, and you saw the actual browser pop up on the background. But you don't really see what's going on in memory. There's a bunch of applications that are running without you even knowing. That just happens as soon as you boot the computer. So in Windows, you have so you have the task manager in Windows, right? And this is Windows 8, so it looks a little bit different. But basically, it just tells you I have these applications and gives you a bunch of information about the application. There are similar tools in Linux and Unix, nice, pretty GUI. But the most basic one, which you guys are going to be using a lot, just clears the screen, but it's PS. It's process. This process by itself is just telling me what I'm currently doing on the terminal. So that's why you only see bash, which is the shell, and the actual command that I just ran, PS. A lot of the commands in Unix or Linux, they have built-in help, so you can do that. That is not the same as that cage. Sometimes that's just a switch that actually does something. That gives you a very quick help file, if you will, explaining the uses of different switches, so on and so forth. So PS tag E, now you see a lot of the processes that are running on the background that you don't even see. So when they start talking about securing processes, you got to look at this list and find out what's necessary to run the system and what's not. For example, on a server, if it's going to be headless, there shouldn't be any GUI-based applications. So there shouldn't be X, there shouldn't be Firefox. That's a GUI based, because it's GUI based. You want to look at those and do something with them, whether it's just stop them, you want to terminate them, whichever the case is. Another useful command is top. So top is going to give you a lot of information about the system when it comes to running processes and memory and stuff like that. It refreshes itself every couple seconds, and whichever process is using the most resources is going to be on the top, and it's going to put them in ascending or descending order. So if your system's running kind of slow, you can come here and look at the processes that are taking up the most resources. So PS3 is basically the same as PS, but it actually lists out the parent and child relationship between processes. When you run a process, sometimes that one process will spawn or run other processes. The first process that you ran, or the first program that you ran, it'll be the parent, and everything else that process, and not you, but the process itself, started running afterwards, it's the children. PS3 will show you that relationship. So you can send signals to the processes. So a signal is basically telling the process, hey, I want you to stop, or I want to put you in the background, I want to put you in the foreground, I want you to die, which is kill tag 9. And that's a very bad way of ending a process, but it's the most effective. You can, let's say there's a process that's kind of hung, it's just sitting there not doing anything. You can send it a signal saying, hey, wake up, what are you doing? And if it doesn't respond, then you can send them another one saying, hey, you're about to die, which is kill tag 9. You can kill or end processes by their process ID. You can also kill processes by giving it the name. Or if it's GUI based, you can type xkill, and your mouse will become a little X, and whatever it's under that X and you click it, it dies. Obviously, you gotta have the appropriate permissions, like anything else. If you're a regular user and you're trying to stop something that's owned by root or the administrator, it's not gonna happen. It's not gonna let you. So.
This will jump in real quick. So you bring up good points. I know for us in Leilahua, we've worked with the task manager and process ID. I had you guys doing the MVP stat, see what was listed on those ports and tell you what process it was. And you go back to the task manager, find the process, and that's how you kind of killed it. So this is very similar in Linux. You see on the left side, it has a process ID. So if it's a process that shouldn't be running, then you can run the kill command on that process ID. And I'm pretty sure he's probably going to show you that right now, how to do something like that.
Yep.
But very similar. So if it's an unauthorized process or a malicious process, same concept as Windows.
So go ahead.
So if we do the xkill on the GUI base and we're going into the process and we click on it, right, and it's going to kill the process, does it actually kill the whole process tree or just that process?
So it's gonna kill the owner of the resource, right? So I'll do it real quick. I'm gonna open two things. So Firefox. Oh, trusty Firefox. And gedit, which is like Notepad. So you can see here I have three things, right? So I have gedit, I have Firefox all the way to the back, and then I have my terminal. So you can see here Firefox, the process ID of Firefox is 2012, how appropriate, because it's about to die. So we survived the end of the world, so we're here, we're good. So gedit is 2032. Now I can type kill. I'm going to pass a signal, with, in this case is kill. Tag 9 means kill, and then Firefox. So, oh, wrong one. I gotta give it, I was thinking pkill, never mind. Sorry about that. So I gotta pass it there you go, the process ID. You saw Firefox disappear from the back, right? So, let's bring it up again. Brought Firefox back up. Let's do. Come on. No, I don't want to do that. There we go. All right, so I do xkill. You see my mouse here, it's just a little bar going up and down, right? As soon as I do xkill, you see a X. My mouse is now an X. Whatever I click on will disappear because I'm the one that's controlling that resource. I'm the one who started Firefox, not root, not somebody else. So if I click on anywhere on Firefox, it dies. I can actually, if I do xkill and click on the desktop, it'll kill it. Like the bars on the top and bottom will disappear, but they'll come back eventually. So another one is kill all. I can just pass it a name. Sometimes that's good, sometimes that's bad. So there are applications that have multiple instances of them running. So you don't want to pass it a name just because you know that's the application that's giving you problems. You can have same named applications running, but they're two completely different things. A lot of malware, sometimes they hide in other directories, but the name that they're running under is the name of a legitimate piece of software. For example, let's say SendMail. You might see 2, 3, 4, 5 instances of SendMail, but if you see one that's running from a different directory, that might be something bad, something you want to look at. You can find any information about any process by going to the proc directory. I mentioned that was the kernel making basically everything that's up in RAM, making it into a file. Whoops. So if I cd into proc, all those directories, and I think they come up in blue here, all those numbers, 1, 13, 10, so on and so forth, those are the process IDs of every single process that's running. That's a directory. So cd into 1513. So you can see all the information that pertains to that running process here. This is one place that you might want to look into if you're trying to find an application that you think is bad. You can find out where it's running from here. You can do many things from here. Okay. All right, so you guys saw xkill, kill all. And very important, you got to have the appropriate permissions. I already mentioned this before, but same as in Windows, when you go to the task manager and you right-click it and you click on End Process, and it says, sorry, you're not allowed, it's because you don't have permissions. Same thing here.